So when you factor any expression, you can factor it kind of two ways. The first way, if you're great at your multiplication tables and recognizing factors, is just saying to yourself, what's the biggest thing that would divide into each of these? So we have two terms separated by a plus sign. The first part of our terms is 12 compared to 21. So we say, what's the biggest number that divides into both 12 and into 21? So the biggest one I can think of is a 3. Then we look at the variables. We have an x, we have an x squared. The biggest one that can divide into both of those is just an x. It's kind of funny because the biggest one is the smallest exponent. Since x to the first is the smallest exponent, that's the biggest one that would divide into both of these. And then this is also kind of a weird one. When we have these parentheses, 5x plus 2y is actually another factor since it's used in both of them. So 5 plus 2y. I don't know why I said 5x. So 3x times 5x, or 5 plus 2y, will divide into both of these. That's your greatest common factor. It goes in front. And then we actually do the division to figure out the other set of parentheses. Since we had a 5 plus 2y on top and bottom, those just cancel each other out. On the first one, since we have an x over an x, those just cancel each other out. And 12 divided by 3 is 4. On the second one, 21 divided by 3 is 7. We had a plus sign that comes down here. X squared divided by x is x. You can think of that a couple of ways. X squared over x to the first. You can do 2 minus 1 and say this is x to the first. Or you could write out x squared as x times x over x. And one set of them cancels and leaves you just an x. So we did 21 divided by 3 to get 7, x squared divided by x to get x. 5 plus 2y cancels out again. So I made my parenthesis way too large. I'm going to move the parenthesis closer in. So you can always factor that way. A second way is to do a factor tree and break everything down. So if we have that same problem, 12x times 5 plus 2y plus 21x squared times 5 plus 2y. We're going to break it down so everything is formed of multiplication. So 12 can be written as 4 times 3. And we know to keep going if it can factor further. 3 is a prime number. The only things that multiply to be 3 are 1 times itself. So we don't need to keep going with that, but 4 can be 2 times 2. So now we have 2 times 2 times 3 times x times, and even though there's a plus sign in here, since it's all in parentheses, this is one factor, 5 plus 2y. So we break the second one down. 21 is 3 times 7. Those are both prime, so we use those, 3 times 7. X squared is x times x. And again, the 5 plus 2y is already multiplying, so it's one entire factor. So now greatest common factor, when you break it down this way, is everything that matches between the two terms. So first term compared to second term, we both have a 3, we both have an x, we both have a 5 plus 2y. That's your greatest common factor that goes in front. And now we've used all of those to get that greatest common factor. Everything else is left over. 2 times 2, which is just 4, and 7 times x, which is 7x. So either way, you get the same answer. We still got 3x, 5 plus 2y, 4 plus 7x, which is just two different ways to do the same type of problem. So the second type is one like this. Again, you can do it either way. So first way, just what divides into each of these. So number-wise, I always look at the smallest, 4. So things that divide into 4 are 2 and 4. So I'm going to check the other ones. The other ones all divide by 2, but we have to make sure to use the biggest, so I'm going to check 4 28 divides by 4, 8 divides by 4, 20 divides by 4. They all divide by 4, so that's our first part. Then I check our x's, x to the third, x to the third, x squared, x squared. We use the smallest exponent, so x squared is the smallest exponent for the x's. We're dividing by the same thing that greatest common factor divides into each of them. And then y's, we have y to the fourth, y to the third, y to the fourth, y to the third. Smallest exponent is y to the third. So that greatest common factor goes in front. 4x squared, y to the third. Then we do the division. 20 divided by 4 is 5. X cubed divided by x squared. 3 minus 2 is 1, so it's x to the first. You do not have to write that 1 in as an exponent, though. Same thing with the y's. 4 minus 3 is 1, so we have y to the first. Plus, because that's the sign that comes after that first term. 8 divided by 4 is 2. X cubed divided by x squared. 3 minus 2 is 1 again. Y to the third over y to the third. 3 minus 3 is 0. And y to the 0 is just a 1. Again, we don't have to write a times 1 in, though. So usually instead of even thinking of that, we say, hey, they match, cross them out. Next one, we bring the minus sign down. 28 divided by 4 is 7. X squared divided by x squared, they match again. Cross them out. 4 minus 3 is 1, so we have y to the first. And last one, 4 divided by 4 is 1. X squared cancels, y cubed cancels. Now, if there had been no number here, if it was just x squared over x squared and y cubed over y cubed, we would still have to write a 1 in, because x squared divided by x squared is 1. We minus our exponents, x to the 0. X to the 0 really is 1. Anything to the 0 exponent is 1. Same thing with the y's, really a 1, but 1 times 1 is 1. So you do have to watch out for that. We shouldn't ever have a term just completely disappear. Even if when we divide, they all go away, it leaves that 1 behind. So you can do it this way, or you can do it the second way. So let me show the second way. I'm going to rewrite the problem. And again, either way works. They are just two different ways to get to the same answer. So we can factor this out. 20 is 4 times 5. 5 is prime, 4 is not, so for us to continue, 2 times 2. And we only use the ends of the branches. We're not going to use the 4 because we factored it further. So we have 2 times 2 times 5 times 3x's and 4y's. Plus 8 is 2 times 4. 4 is 2 times 2, so we have 2 times 2 times 2. 3x's, 3y's. 28 is 4 times 7. 7 is prime, 4 is not. 2 times 2, so we have 2 times 2 times 7 times 2x's and 4y's. And 4 is 2 times 2, 2 is prime. So we have 2 times 2 and 2x's, 3y's. So now we look for the matching pieces on each term. So I'm going to put a little squiggle over each plus or minus sign so we know what's a term. So all of them have 1, 2, and a second 2. No other matching numbers. We have, let's see, 3x's, 3x's, 2x's, 2x's. We have 2x's matching on each of them. And 3y's matching on each of them. So in front we have the 2 2's, the 3x's, and the 2x's. I apologize. 2x's and 3y's. So those cross out from every single term. We've used them as the greatest common factor. We don't need them anymore. Sorry, I just moved the box that was recording. Okay, so now all the leftover from each term is what we put inside the parentheses. So we have 5xy plus 2x minus 7y. Now again, the last one doesn't have any leftover, but we can't just leave it blank. We have to put plus 1. Because, again, really what we were doing was dividing. And the things out front we can multiply back together. 2 times 2 is 4. X times x is x squared. Y is y cubed. And our inside is already as simplified as it possibly can right now. So 2 different ways to get the same answer. We should have the exact same answer as before. 4x squared y cubed, 5xy plus 2x minus 7y plus 1. Good. So just use whichever one you prefer, whichever one works best for you.